and you write Dart code. This is like what's revolutionary, I would say, about Patrol is that now you can only write Dart code to test native stuff inside your Flutter app. Handling location permission dialogs, opening notifications tray to tap on the notification, common scenario that our clients want to check if something happens well in the process after they get a notification. So let's go through some of the features that I would say are default. Hello everyone. I'll try to talk briefly before the lunch about Patrol, a Flutter-first UI testing framework by LeanCode. I'm Mateusz. I'm head of mobile team at LeanCode. I worked there for 7 years. In Patrol, I was one of the first, I would say, guys who wrote a piece of code there. Now I'm more like a technical product owner there. I'm also a Flutter Dart GDE, and you can find me on X Twitter at this handle. So I will try to answer the question that's probably in your head. It's why would you write your own testing framework if there are already first-party frameworks? So it's a very valid question, and I'll try to answer that today. So what's the problem that we want to solve? The problem is that, in our opinion, there's no good enough Flutter UI testing framework in the market, and by UI testing, I mean full end-to-end integration testing. What it means, this problem actually is compiled of three problems. The first one is native automations. You probably know. Who of you tried to run integration tests in Flutter, like with your real app? And most of your real-world apps have some native stuff inside, at least permission dialogues, or some of you can have a web view to have a single sign-on or stuff like that, some authentication stuff, maybe signing in with Google, signing in with Facebook, maybe some location permission, maybe your critical business path includes paying for something and you have to integrate with some native payment SDK like PayPal. And with end-to-end integration testing, first of all, we don't want to mock things because the whole, I would say, advantage of end-to-end integration testing, and besides all of the disadvantages like being slow and costly, it's all about being as real as possible, as close to real-world use case as possible. So we don't want to mock anything. We don't want to mock permissions. We don't want to mock payments. We want to go through the real-world scenario of critical business path. Like, for example, if we had an e-commerce app, I would like to check if I can add items to cart and pay for them and make a successful order, so that business people know that with this version of the app, you can actually, the company can earn money from the app, from the critical business process. So we don't want to mock. And a lot of this stuff is native, and it will be native, and we want to somehow support it. And with integration test, the first-party way, you cannot do that because it doesn't know about the embedder side and the native side. It only knows about the Flutter world. So we basically time out in those scenarios. And often these blockers can be at the beginning of the process. So this is the worst part of it. So the second problem, because the first problem, it was the first problem we discovered. And while we were digging, we discovered another problem while we were writing integration tests. As you can see on the left side, we had to write a lot of code just to, for example, in this case, we want to enter text in 3 text fields, tap 2 things, and that's all. So it's 5 actions and the assert, and you have to write a lot of boilerplate code. Pretty much you have to pump and settle each other line, right? On the right side you can see some complex finder, like finding ancestor or descendant, and it's not human readable so much because it's kind of a low-level API. It's great, it works, it's needed, necessary. It's awesome that we have it inside the first-party tools, but it's pretty low-level, and we as a community deserve some high-level API for that. And the last but not least problem is with end-to-end testing. Many of our enterprise clients, they want to use end-to-end integration testing to actually test things end-to-end on real physical devices using some device clouds like Firebase Test Lab or BrowserStack or Sauce Labs. There are many of those products, and all of those products usually, like not usually, but always, they support native apps, right? Android native way of testing using UI Automator, and the iOS native testing of using XUI test framework. But with Flutter, things are difficult, and for now, to run it with integration tests, usually the device farm has to explicitly support Flutter to support most of the features. So it's always hard to wait for all of those the companies to support Flutter, especially if the client approaches us and just they want to evaluate Flutter from perspective of end-to-end testing. So for example, even if it works, like for example, integration test works with Firebase Test Lab, but as you can see, the test durations are always less than 1 second. I will explain in a moment why it happens like this. And you have no isolation between tests, and you have to do many redundant builds because if you want isolation. So let's talk about all of those stuff. So slow and unnecessary builds. So typically, if you have, I don't know, 50 files with your tests, you have to build with each of those files. For each of those files, you have to build again the app. So you have 50 APKs and upload them so that you have pretty isolated things, but you have to build for 50 times, and it also can cost and is slow. So you can think, okay, I have a workaround for that, and we call it primitive test bundling. You could actually take all the main functions from your files and make some artificial tests that is just bundled of all tests. It will work. It's a good idea, and it seems to work fine. For example, if you approach just a wrong expect in one of the tests, you will get three of those tests passed and 1 failed. But what happens if your test crashes, if your app crashes in one of those tests? Then it brings down the entire test suite. So it's all in one app process. So if it's basically like you would exit with error code, and it just crashes, and you have no reports, no test results. So if you have 100 tests, and after 99 passed tests, your last test will crash, you won't see 99 results. You will just have a crash. And about test durations, you will always see less than 1 second. And that's because integration test works in a way, to put it simple, it just runs all the tests, and at the end of running all of tests, it sends the results to the native side, and the native side just generates fake tests with the same names, and those tests immediately return the result of those tests. So it's always, from the native side, native perspective, it's always less than 1 second, right? Because it's immediately returning the result. So also, because of that, we cannot take advantage of something that's popular on device clouds, which is called sharding. So native tests can be sharded, and sharding means that the farm can split your 100 tests into, for example, 10 groups, and in parallel, they can launch your tests on 10 different devices. So the farm, in this case Firebase Test Lab, has to know about tests beforehand so that they can split them into shards. But if the tests are created and completed after they are run, then it's too late because they are already run, right? So it's by design not compatible with sharding. Okay, so what can we do? Yeah. So who have heard of Patrol today, like before? Okay, so what's Patrol? And this was explanation of why we even decided of making our own testing framework. Patrol is Flutter First UI testing framework, and it means, Flutter First means that it's written in Dart, and it's made for Flutter apps. It's intuitive for Flutter devs, it should be. What it means, it's made for Flutter apps. Usually, Flutter apps contain 90% of Flutter code, right? So we want you to be as comfortable as it can be to work with Flutter code. And this small 10% of native code, we just want you to be able to test it. It's not for testing native apps. It's for testing Flutter apps, but Flutter apps contain mostly Flutter code. So that's why it's in Dart. It has to look like Flutter package. We use Flutter Test for Flutter features because Flutter Test is official first-party SDK for interacting with widget tree. And it's the best API for that, so it's a great low-level API for interacting with that. But we leverage official first-party native frameworks for native features. So we use XUI test for native features on iOS, and we use UI Automator for native features on Android. We try to offer smart defaults because our QA engineers, we made Patrol for our QA team, and our QA team told us that most of the time, they just want some default stuff. Like, for example, if you have multiple things, if you find multiple widgets, probably you want to find the first one. Or, for example, if you want to tap on something, probably you want it to be hit testable, you want it to be clickable, so we wait until something is clickable so that you can tap on it, stuff like that. So we try to reduce the boilerplate on your side. And last but not least, we want to be compatible with all native stuff, native tooling, native device farms. So we want to be seen from outside just as a native app being tested so that Flutter apps can work with all the native tooling like out of the box. So this is the job that we want to do in Patrol to make it work for you. I think now it's kind of working. So let's see the architecture. We have two packages, one plugin and one package. We have Patrol Finders, which is just a high-level API over Flutter test. And it's just a Dart package, like Flutter package. It's not related to native stuff. And for the native stuff, we have Patrol, which is a plugin. It's equivalent of integration test. So it replaces it, basically. So Flutter Finders and Patrol both are dev dependencies. And just to show you what Flutter Finders are, Patrol Finders, I'm sorry. Patrol Finders are finders that extend Flutter Finders. So we don't replace. You can use them. They are, if you test it against Flutter Finders, they are Flutter Finders. You can test with is finder, and it is a finder. So you can use it wherever you want to use a Flutter Finder. And we just try to reduce boilerplate with that. They also work with widget tests, all golden tests, because they are just Flutter Finders. And they are opinionated, and they are faster and easier to write in our opinion, and faster and easier to read and understand in our opinion. So who can tell me why did we use the $? Maybe you know what's the inspiration about the $? Yeah, exactly, jQuery. Yeah, pretty simple, yeah. So it's our paying homage to jQuery, good old jQuery. The one thing that was awesome about jQuery was how easy it was to find something. And we thought we can replicate that. So as you can see, our Patrol Finders are translating to Flutter Finders. So it depends on the type of the object that you pass. If you pass a type, we will find by type. If you pass a string, we will find a a text. If you pass a symbol, it's a pretty old Dart syntax. Maybe some of you know from the days of, I think, mirrors package in Dart. You can use this symbol syntax because we thought it will look like HTML keys, and then we will find by key, but still you can provide a key object inside, and it also works like that and finds by key. You can pass an icon data and a regular expression to find a text containing. So we just translate to Flutter finders. And also we give you some actions, some methods for your convenience as tap or long press or enter text, and they just wait for this finder to be visible or clickable, so you don't have to pump and settle all around your code. Wait until visible, it means wait until something's actually visible for the user. It means that user can interact with it and not only exists in the tree, because normally with Flutter finders you could have this situation when you think that something is in the tree, but it doesn't mean that it's visible on the screen, right? For example, when you have a scroll view or list view and it caches more widgets. You can use @ just to find the fourth one, because we index from 0, of course. Scroll to, it's something also very nice. You can just, if you want to scroll to my key, you can use myKey.scrollTo. It will try to scroll, because usually you have one scrollable, so it will try to use the scrollable that is on the screen to scroll to this widget. But if you want to specifically tell what scrollable you want to use, you can also do that, and there are a lot of properties inside to modify. It's just that the default behavior is the behavior that you would want most of the time, right? You can also chain it, as you can see, scroll to and tap, and we will take care of the future unwinding inside. We also export which method, which is the same like widget predicate in Flutter test finders. So you can find a container that color is red, for example. Okay, so we can rewrite the test that was in the beginning of the talk on the left side, and now we can see that we have, I don't know, 8 lines, 7 lines of code that's pumping the widget of your app, entering text, entering text, entering text, tapping 2 times, and we wait until something's visible. So in our opinion, it's just reducing the boilerplate so you can know what you meant 1 month ago while writing this test. Also with descendant and ancestor, we thought we can also simplify that. So if you change the $sign, if you do, dollar is also a function on a dollar, like a method on a dollar of patrol finder object, you can do $. It means that we want to find a subscribe text inside a list view. To not use this huge descendant syntax. So it's a subscribe inside list view, and we tap on this subscribe. And it's not only that, because it's actually, you have to solve more things inside. It's not only about finding, it's also that typically you have to wait until the list view is visible, you have to wait until the subscribe is visible, and then you can tap on it. So we do it inside. This is more tricky, because on the left side, as you can see, we have ancestor and descendant. It's hard to actually know what it means, so we can check. So we have a containing. Containing is like an ancestor, because typically it's when you would want to use ancestor is the situation when you want to find, for example, here, a list style containing activated text, but you actually want this list style to be returned, not the text. You just want the text to identify it, to somehow uniquely tell the framework what you want to find. So we thought containing means something like, if you read it in English, it's more intuitive. So a list style containing activated, and then this list style has a learn more key, and we tap on it, right? And wait until visible on all of this stuff and pump and settle. The last but not least about the finders, remember that the default tooling is still available. If you use patrol finders, don't be afraid that you cannot use widget tester. We have a tester object, it's widget tester, and you just can use widget tester because we extend, not replace. Okay, let's go to the main course, that is Patrol plugin. So it's the place that enables you to play around with native stuff. So now, if you use Patrol test with plugin, you have a new object available on the dollar object. It's called native, the property native, and everything that's after native is related to the native interaction. So $.native, as you can see, we have some convenience methods for you already for the default use cases, like enabling cellular, because you probably want to check how your app behaves in offline mode, disabling Wi-Fi, maybe toggling some system theming, handling location permission dialogues, of course, as well as other permission dialogues, opening notifications tray to tap on the notification, common scenario that our clients want to check if something happens well in the process after they get a notification. And you write Dart code. This is like what's revolutionary, I would say, about Patrol is that now you can only write Dart code to test native stuff inside your Flutter app. So let's go through some of the features that I would say are default. This is about notifications. So as you can see, you can grant permission when in use. It's generic. No matter if it's a notification permission or some other, it will try to just tap on the allow button on both platforms. And then we can press home, open notifications, tap on notification by selector. Selector means something like a finder, but for native stuff. We didn't want to make you confused that that finder is both native and Flutter, so we named it selector, but it's how to find a view on the native side. So also, as you can see, we support generic permissions, just granting it only this time when in use. With location, you can set coarse location, precise location. We also have method for that. Going further, yeah, you can actually test everything because we give you the method of tap, give you the method of enter text by index, swiping natively by coordinates, tapping on some selectors. So in this scenario, we opened Google Contacts app and just created a contact using Patrol, even if it's not our app. Because if we are in this instrumentation mode on Android and iOS, we can actually tap on other apps as well. So we can go outside our app, go to Google Contacts, make a contact. For example, one of scenario to do is, for example, if you reset your password, you can go to Gmail and click on the link. And of course, moderation is a virtue. Remember that you don't want to use it. It's really flaky because you depend on other apps that you have no control over. But still, it's good to be enabled to do things, right? We don't encourage you to test other apps, but maybe it's something that's a huge enabler for you, and then you can use it. All right. So to make it work, we also have to deliver a CLI with it, because it's not so simple, and we cannot use just Flutter test with it. So if you go to Patrol documentation, and in Getting Started section, you would see this Dart pub global activate Patrol CLI. It's our CLI as a global Dart tool, and it's Patrol in your command line. And we have a couple of commands like build, develop, devices, doctor, like Flutter, test, and update. So doctor is something because we also need some kind of environment set up on your side, like Java, InPath, Android Home, ADB. Also to use iOS physical devices, we need iDevice installer to install apps to the device and stuff like that. And usually if you have Flutter already, Flutter finds Java in its own way in Flutter tools. It just finds Android Studio somewhere on your computer and finds the Java bundled runtime inside. And it might happen that you don't have those environmental variables set. That's why we made this Patrol doctor and encourage you to use it before using Patrol. It's all in the docs, of course. And also we have Patrol develop, which is something where it's a mode when you can develop tests. So what it means is typically our QA team told us that they would want to write some test, write a line, and hot restart the test, rerun the test from the beginning so that they can see if what's happening. You can add new line, save the file, hit R in the console. So it's pretty much like hot restart. It takes advantage of Flutter hot restart because hot reload is not giving us anything because the test is already, passed or failed. So we want to rerun the test. So to develop apps, tests is just faster. You can use Patrol Develop to try it out. And we also have a DevTools extension, which is pretty cool, because if you use native stuff, you don't know what are the identifiers of native stuff. For example, if you use third-party SDK, like PayPal or something, or Stripe, I don't know, some third-party SDK, and you want to click on some button, you don't know what's the ID of this button. So we thought, okay, normally you would have to dump from ADB, you had to dump a huge XML file with a lot of XML nodes that are equivalents of the views in the screen, and you would have to find it manually. So we thought it would be nice to have equivalent of Flutter Inspector, but for native views, so that you can see what's happening on the native side on your screen. So you can use DevTools extension, of course, with Patrol from Flutter 3.16, because that's when it landed on stable. And last but not least, it also works on device farms. We have projects for our clients that we can finally run Flutter integration tests on browser stack, on Firebase Test Lab. We also have a project with Sauce Labs. We have a project with emulator.wtf. We have a project with Marathon Cloud. So at least those 5 farms are executing tests well with real test durations, real logs, real videos. As you can see, this is a video. This is Patrol testing Patrol itself on Firebase Test Lab on our GitHub action. So it's really cool for us that we finally achieved this moment when we can take advantage of those native tooling and use it with Flutter apps, right? So to finish it, we have extensive docs. It's always funny because it's not true. We are open source. It's free. Many people approached me and asked, what's the price of Patrol? So yeah, this is an open source tooling. You can just use it. It's just a plugin on Pub. So you don't have to pay for that. And also, we develop it for us. So I know you don't trust anybody, but you can trust us. We also need Patrol, so we maintain it. And we use it to test several production-grade apps, some enterprise-level apps. And last but not least, to tell you about us, 1 minute. We are a LeanCode, a Flutter agency. If you need to have some consultation about Patrol, you can find it on our website, or you can scan this QR code and we can hop on a call to help you with setting up Patrol, setting up CI/CD with Patrol, your custom native tooling, maybe your custom enterprise environment, maybe on-premise stuff, cloud stuff. It doesn't matter. We can just help you with your testing strategy, stuff like that. We also have our own QA Patrol engineers for that. And yeah, thank you. You can help us. You know how. This QR code is our GitHub site. Like, you can give us a star. Please give us a star and like us on Pub. Thank you very much again.
Thank you so much.